All right, hello everybody. This is Mrs. Masteller once again, and we are diving into our next section, which again, kind of skipping around a little bit. So we did 7.1, we did 7.3. 7.5 is now titled The Properties of Logarithms, which is probably one of the most important, if not the most important section when it comes to logarithms. Okay, so pay close attention to these properties. You have to know these properties in order to actually advance on and learn anything else really about logs, because we're going to be using these properties in the next few sections when it comes to solving equations with logs and things of that nature. Okay, so the properties that you have to know, the product property. Well, product we know means multiplication. So we are going to be multiplying of some sort. But basically, if you have two logarithms, let me just kind of give you an example here. If you have something like log base b of m, and you're adding to it log base b of n, if you wanted to condense these two logarithms, okay, so you always want to condense your logs to make it into a single log. How you're going to do that is by multiplication. So you even see in these first three examples going across underneath, you see a plus sign, right, separating all the logs in between. So if you're adding two logs, the key thing too is the bases must be the same. So as long as the bases are the same, which you're not going to see any, at least here in Algebra 2, that are not going to be the same, that's something probably going to be a little bit more advanced. Maybe next year if you go on a pre-cal or anything like that, you'll probably see some uncommon bases where you have to do a little bit more work. But as long as the bases are the same for the two logs, what you're going to do to condense them, so you keep the log base b, but you want to multiply m times n together. So whatever these two values are, you're just going to multiply them, and that'd be it. Okay, so this would be your solution, and then obviously just simplify the logarithm if you can. So for example, coming down here to example number 1. So log base 6, right? We got log base 6 of 4, and we're adding to it log base 6 of 9. So to condense this log to be a single logarithm, this would just be log base 6 of 4 times 9, which is log base 6 of 36. 4 times 9. Now simplify the logarithm. So again, the question is, 6 to what power is going to be 36? So our final answer then would just be 2. Okay, so you want to, again, condense the logarithm, simplify it if you can. So example number 2, condensing this logarithm. Again, bases are the same. They're both 1/3. So to condense it, since there's a plus sign separating them, I'm just going to keep this as log base 1/3. And now we're multiplying 27 times 1/9. So 27 times 1/9 would just simply be 3. And now you want to actually simplify the logarithm. So again, the question is 1/3 to what power is 3? That's the question. And that's going to be -1 as my final solution. And the next one, number 3, so log base 6 of 12. We're adding to it log base 6 of 18. So that'd just be log base 6. Now you want to multiply 12 times 18. You should get 216. And now simplify the log. So what is log base 6 of 216? So again, here's the question. 6 to what power is 216? And the answer would just be 3. Okay, so anytime you see a plus sign separating your two logarithms to condense it to be a single log, you're thinking multiplication. So plus sign is when you want to multiply. Addition is multiplication. And now quotient property, pretty similar. Okay, so quotient we know means division. But, so you even see in these next examples, you see a minus sign separating the two logs, right? So pretty similar ideas, what's above. So addition, you're really going to multiply to condense it. So if you have something like log base b of m minus log base b of n, you're going to condense these two logs. So subtraction, you want to think division. This would just be log base b of m divided by n. And it's always the first one divided by the second one. Okay, so sometimes you want to switch it around just depending on which number is bigger, but you don't want to switch it. It's always the first one with the log. You want to divide it by the second one. Okay, so expressing these as a single log and then simplifying again if we can. So if I simplify this logarithm, okay, what that's going to be, it's going to be log base 5 still, but I want to divide again 100 divided by 4. So the first one divided by the second one, which would just be log base 5 of 25. And now simplifying the log, what is log base 5 of 25? 5 to what power is 25? My final answer would just be 2. And for the next one, for number 5, condense this down. This would be log base 7. 49 divided by 7 is obviously 7. Simplifying the logarithm, That would just be 1 because we know that 7 to the first power is going to be 7. So my answer would be 1. And the last one, number 6, condensing this log. This would be log base 2. Again, I'm doing 12 divided by 48, which would just be 1/4. And now we got to simplify the logarithm. So the question is 2 to what power is going to be 1/4? And that would be -2. Okay, so we've seen product, we've seen quotient, now we have the power property. So the power property works like this. It kind of works in both directions. So if you have something like log base b, let's just say of a to the p. So I got a power, I have an exponent. What you can do is you can bring that exponent out front to make this p times log base b of a. So you could bring this out front, and you can also, like I said, this kind of works in both directions. You could also push this back to be the exponent once again. So it just kind of depends on what you're trying to do. Might make it easier one way or the other. But using this property now for these next examples, so we are going to simplify these logs with exponents, express it as a product, simplify if we can. Okay, so for number 7, it says log base 2 of 32 to the 6th power. So we could, we could find what is 32 to the 6th power and then simplify the log, but look at that gigantic number. So we really want to try and figure out 2 to what power is going to be whatever that number is. So what is that even? 1,773,000,000, it looks like, 741,824. No. So what makes life a little bit easier, again, is using the power property. So what I'm going to do is I'm going to bring this exponent out front to make this 6 times log base 2 of 32. Okay, now simplify the logarithm. It's a lot easier here. 2 to what power is going to be 32? That one's not too bad. So if you know your powers pretty well, I know it's 2 to the 5th power, but play around with some numbers a little bit, and it's 2 to the 5th power. 5 would be the answer to log base 2 of 32. So we're really just doing 6 times 5 here, which ultimately my answer would be 30 then. Okay, so you get to your answer, obviously, like I said, a lot faster. So for number 8, again, I'm just going to use the power property. So I'm going to bring my exponent forward, making this 4 times log base 3 of 1/3. Now simplify the logarithm. So 3 to what power is 1/3? That's the question. 3 to what power equals 1/3? That'd be -1. So we're really just doing 4 times -1, where my answer would be -4. Okay, and the last one, so I'm going to bring the 20 out front, making this 20 times log base 8 of 4. Now simplify the log. All right, this one's a little bit trickier. So I'm asking you 8 to what power is 4? That's the question. So you're trying to figure out what is this exponent, right? I'm going to make this a little different, okay? I'm going to change my bases here just to make it a little easier on myself. So thinking about 8 and 4, what common base do they have? I can change them both into a base of 2. So 8 is the same thing as 2 cubed, and 4 is the same thing as 2 squared. Okay, so see how I got that common base on both sides? All right, I'm not changing again the value of the problem. It's still the same problem, but I'm just changing basically what it looks like. So instead of 8 to the x, now it's going to be 2 to the 3x, and that equals 2 squared. So once you have the same base on both sides, you can get rid of the bases altogether and just set the exponents equal. Set 3x equal to 2. Solving for x, it's going to be a fraction actually, it's 2/3. Okay, that is our solution. These just cancel. So 8 to the 2/3 power, if you double check it too, if you're not sure about it, if I raise 8, to the fraction, to the 2/3 power, it should come out to be 4, like we want it to, and bingo, there you go. Okay? So I'm going to take now, replacing the log base 8 of 4 with what it is, it's just 2/3. So I'm really doing 20 times 2/3, which gives me 40/3 as my final solution. All right. So 3 properties down. The next one, inverse properties. This really just comes from recognition. So if you recognize these right away, it's just going to make your life one heck of a lot easier. Okay, so if you have something like log base b of b to the x. So if these bases are the same, the base of the log and the base of the exponential are the same, they essentially just cancel each other out, and your answer would just be x. And that's it. Okay, and similar idea too, if you had something like b raised to the log base b of x, something like this, again, if the base of the exponential and the base of the log are the same number, they're the same value, your answer again would just simply be x. They cancel each other out. So that's why we mean inverses. So like I said, it comes from recognition. So it says recognizing inverses, simplifying each expression. So example number 10, as you see, the base of the log, the base of the exponential, they're both 3. So my answer is just simply 11. For 11, though, we got a little tweaking we have to do for this one. So I can rewrite this to be log base 3 of 3 to the 4th, because 3 to the 4th power is 81. So now, once again, once you see those same bases, they're both 3, right? Those essentially just eliminate each other. My answer would just be 4. And then same thing with number 12. Base and base, they're both the same. My answer would just simply be 10. Okay, so the faster you recognize those, the easier your life will be. So on to the next page. It says common logs. Use a calculator to evaluate each expression to 4 decimals. So now we're going to be actually using the log button, which you've probably seen in your calculator. You just probably didn't know what it was used for. So underneath the green button, you see log, right? All we're going to do is type in log 6, see what it comes out to. Okay, so if I type in log 6, and again rounding to 4 decimals, you get about 0.7782 would be your answer. So 0.7782. The next one, we're doing log 15. So I'm just going to type in log 15. And you should get about 1.1761. So 1.1761. And then the next one, you guys can do a little bit of practice too. So typing in log 1.1, you should get 0.0414 is what I got. And then log of 0.3 comes out to be negative 0.5229. Okay, I want to stop and pause here and think about, what did we just calculate? Okay, what did we just find? What does that answer even mean to us? Well, if you remember, if you just see log by itself with no base, we automatically assume this is log base 10, right? So these are all base 10 logs, and that's the only log that your calculators will do. It has to be a base 10 log, okay? What we just found technically is this is the exponent. That's what your solution is. Again, when you're simplifying a logarithm or evaluating a logarithm, your answer itself, what you're trying to find, is the exponent. So basically, if you raise 10 to this power 0.7782, it should come out to be about 6. So let's just kind of double check that first one at least. So if I take 10 and I raise it to that exponent, 0.7782, and look at that. It comes out to be about 6, right? So it's not exact because, well, my answer is rounded too. But it comes out to be pretty much 6, exactly on the dot. And then for B, if you double check, if you raise 10, let's just check the other one. If I raise 10 to the 1.1761, it should come out to be about 15. And there you go. There's your answer. Okay, so again, you're doing base 10 logarithms and you're solving for the exponent essentially, is what we just found. And the reason why we have to know that is because we also have this thing called the change of base formula. Okay, so I want to give you an example. What if I asked you to evaluate log base 7 of 14? If I told you to find log base 7 of 14? Well, you can't, because you'd be sitting here asking yourself, 7 to what power is 14? And guess what? You can't do it mentally. You can't do mental math with it, which is why we have this thing called a change of base formula, where we're literally going to be changing the base. Okay, we're changing the base to be base 10 to have something that we can actually calculate. So how this works, if this was my case scenario, all you'd have to do is you're going to do log 14 and divide it by log 7. So like I said, we literally just change the base to being a base 10 logarithm. Okay, this is the formula that you'd want to walk yourself through to actually calculate this. So if I type this in, if I do log 14, right? So what is that? Log 14, and now I want to divide it by log 7, and I get to my final solution. Okay, so my answer comes out to be about 1.3562 in the end. Would be my solution. All right, so pretty cool. You could also type it in like this too. I believe that this works as well. Let me just double check. Log 14 is a fraction. And then again, you're dividing it by log 7. I'm just going to close my parentheses just to be safe. Actually, there's one too many parentheses here now, isn't there? So log 7. So let's try that out. So same exact answer, right? Okay, so basically if I take 7, if I raise it to that power, if I raise it, let me do it like this. I raise it to that power, it should come out to be 14. And there you go. So 7 raised that exponent to the 1.356207187 is going to be 14. Okay? So if you can't do the mental math for it, you could always just simply do change of base. So we're going to practice using that for the next examples that you see, evaluating each expression in terms of common logs and approximate the value again to 4 decimals. So for number 14, again, we could probably actually do this one because it's 9 to what power is going to be 27. We could work this one out. But we could also just use a change of base, doing log of 27, dividing it by log 9, and then getting to our solution. So let's try this one. We got log, again, 27, which is that number. And now I want to divide it by log of 9. I'm going to close my parentheses. And you get 1.5 exactly. So it comes out to be 1.5. So like I said, since it comes out to be a terminating decimal, we definitely could have worked that one out by hand, but not so much for 15. So 2 to what power is 35 is the question. So we definitely, there's nothing that we can even think of. I mean, we know that 2 to the 5th power is 32, and then 2 to the 6th power is even bigger, though it's 64. So it's somewhere between those two values. It's going to be somewhere between 5 and 6, basically, is where we're getting at. But you could find that actual number just by using change of base. So doing log of 35, dividing it by log 2. So if I type in log 35, there's log 35, and now I want to divide it by log 2. And like I said, it's between 5 and 6, a little bit closer to 5, obviously, because, well, 2 to the 5th power, again, is 32, and we're trying to find 35. So it's just a smidge above 5. Rounding this to 4 decimal places would be approximately, this comes out to be about 5.1293. And there's your solution. Okay. The next one then for 16, again, the question is 3 to what power is 7? So all you have to do is log of 7 and divide it by log of 3. And I'll just go ahead and write down the answer to this one. This should come out to be about, I got 1.7712 is my solution. And the next one, again, the question is 32 to what power is 8? We could have probably worked this one out as well, but you could also just simply do log of 8 and divide it by log of 32. And this one comes out to be, not about actually, like I said, this one comes out to be an exact solution. This comes out to be exactly, you get 3/5. So you can say 3/5, or you can also say, I think that's 0.6 as a decimal, so either way is correct. All right? So now, for this next part, we actually don't do these anymore, so I'm not going to worry about these per se. All right, so that next section, those next 3, I'm not going to worry about those. But now it's basically all jumbled together. So this is more so how your homework and how you're going to see things in the future, just kind of all jumbled together. You have to know exactly how to simplify it by knowing these properties pretty darn well. So for number 21, because I see a plus sign separating the 2 logs, if I had expressed this as a single logarithm, I'm going to condense this by multiplication. Again, addition means multiplication. So I'm going to keep this as log base 1.5, and now I just simply want to multiply what's 11.25. Get my finger back. 11.25 times 5 is what we're doing, and you get 56.25. We don't have to simplify it. It only says to express as a single log. That's all you have to do, so we're done. So same thing for 22. I see a plus sign in between, so I'm going to condense this. I keep this a log, again, technically base 10 since there is no base, but we're just multiplying 500 times 5, and that'd be 2,500. And there's my answer. For the next one, there's 2 properties happening. Okay, the first one, you got to push back those exponents. That's the first thing you see. Anytime you see a number in front of a logarithm, you got to push it back to be its exponent. So this is really going to be log of 6 squared minus log of 27 to the 1/3. Okay, so it's just the value. You don't want the minus sign to come with it. It's not negative 1/3. It's just simply 1/3. Now I'm going to simplify this. So this is just log of 36 because that's 6 squared And then we're subtracting log of 27 to the 1/3 would just be 3. Okay, so that was the first property to take care of, the power, the product, or yeah, the power, the exponent. So now we want to condense these two logs to be a single log. Since I see a minus sign in between though, I'm thinking division. So I'm going to keep this log and we're just dividing 36 by 3. So my answer would just be 12. So log 12. Okay, the next one again, there's two properties. First of all, exponent, I'm just going to push that back. So this will be log base 5 of x cubed minus log base 5 of 8. Okay, so that's the only one that had an exponent. So now condense these two logs to be a single log. Again, minus sign means division. So this would be log base 5 of x cubed over 8. And that's about all you could do. You can't do any more. Obviously, I can't really divide an x cubed by an 8, but that would be your final answer. 25, once again, two properties. Push back those exponents. So this would be log 16 to the 1/4 minus log 64 to the 1/3. Again, simplifying this now, what is 16 to the 1/4? What is 64 to the 1/3? This would be log 2 minus log, this would be 4. So 64 to the 1/3. And now last thing, condense these two logs to be 1. Again, I see a minus sign, so I'm thinking division. So this would be log, when you do 2 divided by 4, that's just going to be 1/2. So log 1/2. So 2 over 4 reduces down. And the last one, number 26, I see a plus sign separating, so I'm thinking multiplication. There's no exponents for this one to worry about. So I'm just going to go ahead and jump into my multiplication here. We got to multiply x minus 2 and x plus 5. But how do we multiply those two together? You got to FOIL. Okay, so don't just leave them side by side like this. You have to actually continue on with the multiplication, which would be, so we have log base 2, we have x squared, we'd have 5x minus 2x, so that would make that a 3x, and then minus 10. There's my solution. Okay. So condensing logarithms. The next one's it just says a simplify. So for number 27, the question is, if I'm simplifying this logarithm, I'm trying to find 7 to what power is 2401. So we can kind of play around with some numbers. Let's try and see if we can do some mental math. I know 7 squared is 49. Let's try 7 cubed and see what that looks like. Well, that's too small. Let's try 7 to the 4th. Is that it? That's it right there. Answer would just be 4. Okay, for 27 though, if you notice, these two bases are the same. That's the inverse. Okay, again, those essentially just cancel out. My answer would just be simplified x plus 5. And same thing for 29. The bases are the same. The exponential and the log. Essentially, they eliminate each other. So my answer is just 3.96. And evaluating at the bottom now, so number 30. Again, check and see if you can do the mental math. It's 1/3 to what power is 27 is the question. And the answer would just be -3. Okay, so if you double check it too, you can always try that out. 31, the question is 49 to what power is 343. We could work this one out by hand because again, if you think about the common base they have, it would be 7. So 7 squared is 49, 7 cubed is 343. So again, I'm changing the problem basically to be 7 to the 2x instead of 49 to the x, and that equals 7 cubed. So now once you have the same base, just set the exponents equal. Set 2x equal to 3, dividing both sides by 2, and we're looking at 3 over 2. But what else you could do for this problem too, if you don't know by looking at it, you could just simply do change a base. You could just simply calculate log of 343 and divide it by log of 49. So let me just show you that real quick. If I type in log of 343, okay, and I want to divide it by log of 49, comes out to be 1.5, which is the same thing as 3 over 2. Okay, so it's all the same answer there in the end. And the last one, number 32, question is 3 to what power is 7, right? That's my question, which doesn't exist. We know 3 to the first power is going to be 3, and we know that 3 squared is going to be 9. So it's somewhere between 1 and 2. So if you can't do it, again, just simply resort back to your change of base. Log of 7 divided by log 3. So if we type this in, log 7, and then we're dividing it by log of 3 And it should come out to be about 1.7712 would be my solution. So it's approximately 1.7712. And there you go. Okay, so now we know all the properties of logs. Again, you will be seeing this most definitely all throughout basically the rest of the chapter. Okay, so practice these properties. They're the most important thing you gotta know before continuing on with anything else. But as usual, let us know if you have any questions and have a great day.